Hi everyone, we are Talking Hands. This is our team, Alex, Syed, you, and Shanil. So the inspiration comes from this pandemic with COVID-19 and quarantine. We find that a lot of people that have speaking disabilities are facing difficulties communicating with their peers through Zoom for school, remote work, and other avenues of being online and not being able to properly communicate using words. So our solution is Talking Hands, an app that allows them to communicate virtually using ASL. So what's gonna happen is the person is gonna start signing to the webcam, and the webcam's gonna start tracking the hand gestures, and then the program will translate those hand gestures into ASL, or translating the ASL to English, and the English text will be then outputted and read out loud through the speaker, so that way the people that are speaking impaired can actually be heard through the video. We're going to go through a quick demo of what it's going to look like.
Go sleep.
So as you can see in the demo, our program runs on the desktop. And so how exactly did we do this? Our front end consists of PyQt, which lets it run natively on Windows as well as Mac, and possibly Linux. And all the buttons and interactables are through that framework. We capture the webcam input through OpenCV, and then we pre-process the image with OpenCV as well, pass that on to our TensorFlow model, and then that produces an output and gives back the letter. And with the letters, we then send it over to Google, who will then do the text-to-speech processing, send back an audio file, which will play in the application. To know more about our TensorFlow and how we trained our machine learning model, I'll pass it off to Syed, who will talk about all our technologies we use in the backend.
So for backend, we made a great use of Microsoft Azure Custom Vision AI model. We basically got our data set from Kaggle and fed the model with certain English letters that are equivalent to their ASL letters. And that way we were able to train the model with different environments and different lighting so that the model is really understanding the gestures. And after we got done training the model, we exported the model into TensorFlow, and based on the TensorFlow model, we were able to implement that model into our desktop application, which was built in Python. So what were the challenges that we faced while we were building the application? So the first challenge was the data sets. There were a lot of data sets where we found inconsistencies, and the image recognition software, the image classifier, would not understand the data that's being processed. So it was a challenge to find the right data set that is consistent with its form. A lot of times people mixed up their data sets on Kaggle, and that was definitely a big challenge for us to actually go in and filter out certain data sets to feed the model with the right ones. The integration was the second challenge. We used a lot of different ways to integrate our Azure model into our desktop application. And so we decided on using TensorFlow. But since we were relatively new with the TensorFlow technology and integrating a machine learning model to our desktop application, it was a big challenge for us to learn and then implement such technology within the strict time constraint. Another challenge that we faced was OpenCV. Since we built the desktop application using Python and everything at the backend is done using TensorFlow, we had to find a way to integrate the two, OpenCV and TensorFlow, and make sure they're talking to each other constantly so our data is being processed correctly and in a very efficient manner. Another challenge that we faced was the text-to-speech. It was our first time using these technologies, so we did not have any prior experience or prior knowledge. So we learned these new technologies and implemented them to our desktop application. Talking about accomplishments, we are really proud of that we created such a system, such a desktop application that uses machine learning to solve a real world problem. We used Microsoft Azure's custom vision AI and integrated the model with the front end graphical user interface, and at the same time processed the resultant text to speech. And we are really proud of using such technologies. Having no prior experience, this gave us a really good chance to learn these technologies and implement them to a bigger level project. Well, what are the next steps to this application? Well, our main goal was to ease the process, ease the communication process for people who have difficulty speaking over these virtual platforms. So definitely our next steps include integrating our application with video conferencing apps, including Zoom, including Microsoft Teams, including Google Meets, and at the same time also have it available on mobile apps, so it's not just compatible with your personal computer. And another goal that we had that we'll work on is to reduce the latency and improve the model. So feeding the model with more data sets and making it aware of different surroundings, different lighting, so it gets better with each iteration. And lastly, thank you so much for watching our presentation. I really hope you liked our idea. And if you have any questions, please feel free to let us know. Thank you.